All right. Welcome, guys. There's 9 participants here, plus the two, Soumya and I. Um, so this is a laboratory session for all of us. Okay. We will start with my um, part of the presentation first, which is the more practical part of all of us research workbench. And then if Dr. Alemi joins, then um, we can go. Oh, Dr. Alemi will join. We'll just wait for him. Okay. While waiting for him, okay, I will go with the first slide. So what is this session about? So this session will show you how I learned all of us. I did a lot of exploration with all of us for the past several weeks that I've had access to it, particularly for a research project that I have with Dr. Alemi, and also a data mining project that I will submit by the end of this semester. Okay. Do not take this as a training session because I'm not by all means an authority on all of us. But if I will show you everything that most of the things that I've learned, and if you have anything that are more detailed or more deep into all of us, I suggest you take the training course and raise questions to the support team. That's what I do. I just took the simple training sessions, and then when I face some questions like how do I, for example, import an external data set, and those kinds of questions, I just ask the support team. They're very prompt in answering. Okay. Dr. Alemi will join us, but in case you have questions on the top of your mind, and you're not comfortable with speaking out in this session, you can put a question in the chat, particularly for the project question, because I won't be able to answer project questions. Um, so just put a hashtag like hashtag project question at the end, and we will collate everything and have them responded to after this session if they are not responded to within this session. And then finally, after the demonstration, we will break out into small groups so that you can try to create your data set and help each other with your all of us exploration. Okay? Okay, now for this session, at least for my part, we will cover how to create a cohort, how to create concept sets, and how to create a data set. Okay, I can show you some parts of data preparation, as well as some parts of some parts of joining data sets into an input file. Okay, but I have not completed at least for the third data set that we will use for this, because there's one issue that I was only able to solve early this morning, like 1 a.m. So I didn't have time to convert that into an R code. I was using Python for my machine learning project. Okay, so once you have created your data set, for each data set, you can do some data preparation steps before joining to a data input file. Please note that everything, all of these things can be done within all of us. But if you are more comfortable doing data manipulation or programming in your own device or in your own server, you can also export this data input file outside of all of us, as long as it does not have any personally identifiable information. All of us will actually have you affirm that when you're exporting data, there's no personally identifiable information. Okay. Once you have that data input file, you'll proceed with the data cleaning steps, and the model training and reporting. Okay. And I think Dr. Alemi is here, so I will stop first because I think he has some things that he wants to tell you about the project. Hello, Dr. Alemi. Stop sharing. Hello, Dr. Alemi, can you hear us?
Hi, folks. Sorry for my system having so much trouble. Vlad, I'd like you to actually continue and I listen, and then afterwards I can talk about the project.
Okay, I will. I will do that. Let's share the screen. Okay, now. So for this particular session, we will generate the 3 data sets that we require for your project, but in the context of breast cancer. I know that all of you are exploring different types of cancer. For this particular example, I'll just go for breast cancer because my final project for for my data mining class is using breast cancer. So it's easier for me to convert to the analysis data frames that we will use. So the 3 data sets that we will do are the person demographics data set, the person diseases data set, which has 590 diseases in that data set, and then a data set containing all people with the particular cancer that you are studying. So in this case, it's breast cancer. I will describe to you later why I chose this particular 3 data sets. I will just mute everyone. There you go. Um, why I chose these particular 3 data sets when we discuss how we will design to create concept sets that we will use for our data set. Okay. So let's go on with the let's proceed with the demonstration. Okay. So for the demonstration, we will have 4 steps. And then when we have time, I will show you some data preparation steps that I have done as well. Sorry, go back up. So the start is to create your cohort. Okay. So this is the All of Us research workbench. Okay. When you enter All of Us, you will be in a home page. Particularly for this session, we are expecting that you already know how to create your workspace. For this particular set demo, I created a workspace, an educational workspace. I think it's easier to do an educational workspace. But if you will publish, you have to create a research workspace. Okay, I think you can do that later on. You can transfer all of your work from educational workspace into a research workspace if you decide to publish. Okay, but right now it's easier to do an educational workspace. So you can do 2 things when you enter your workspace. You manage your data or you analyze your data. So data and analysis as shown by these 2 tabs. So for cohort creation, we need to be in the data creation tab. Okay. To create the cohort, you will click this plus sign beside cohorts. Okay. You only need to create cohorts if you need a specific set of the population in all of us. All of us has more than 490,000 participants in its data set. So there's a default data set called all participants. So sorry, there's a default cohort called all participants. But if you want a specific population based on your inclusion and exclusion criteria, then you have to create a cohort. So let me do that now. So I click that, and the first thing that you will do is put in an inclusion criteria. So I know that for breast cancer, there are some instances that males can have breast cancer, but for this particular demo, we will limit our study to females. So to do that, click on Add Criteria, and then select what criteria you want to add. You can add data from the All of Us program, meaning surveys and demographics of the persons, or EHR domains such as conditions, procedures, drugs, labs, observations. Okay. So for adding females, we go to demographics and sex assigned at birth. We're And then you can there's 4 valid values for sex assigned at birth in the database: female, male, not female, not male, or preferred not to answer or unknown. So we will just select female, and we finish review. We save the criteria, and on the right side, you will see that there are 248,000 people who met our inclusion criteria inside the database. You can select some different breakdown of that data frame of that data by clicking refresh here and selecting your grouping and clicking refresh. You can add other criteria, inclusion or exclusion criteria. So now we have added our first inclusion criteria. It's now separated into inclusion criteria and exclusion criteria on the right. So include participants on the left, exclude participants on the right. So that's your inclusion and exclusion criteria. Within each box like this, okay, if you add a criteria within a box, it will be an or, right? It will be an or criteria A versus or criteria B. If you add it on a box to the bottom of that inclusion criteria, it will be an and. Okay. You can also, for example, add an exclusion criteria. For example, even if we have it, we can, if we're interested in studying non-white people, we can exclude white, right, in our cohort. And it will have the same box, like if you add a criteria within the box here of group 3, it will be an or. If you add it in group 4, it will be an and. Okay? And there's like 109,000 females that are non-white in our database. I will remove this exclusion criteria first. Okay, this criteria has been deleted. So we reverted to a cohort that's just females. Then I will just create this cohort. I'll call it all females. Put a description if you like. And then we have created our cohort. Before we proceed with the next step of our demo, I would like to show you that you can actually explore the contents of all of us by creating a review set. This will help you get familiar with what are the data that you can get from all of us. So when I click that create a review set, you can click this plus sign again and choose a review set name. For example, top 100. I'll just get 100 participants. I wanted to browse them. Then create set. And now we can see that these are all the top 100 patients in persons in our cohort, participants in our cohort. We can click one of them, and these are all the data that all of us has for those participants. So events, conditions. Well, let's go to conditions, right? Um, procedures, drugs, and you can explore. Okay. So that's it for cohort creation. Is there any question before I proceed? Okay. Silence
Hi,
means
Vlad. Can you?
hello, who's this?
Hi, I'm
Hello,
Shravya.
Shravya.
So I could create the cohort, but how do I get to each participant again?
Oh, so there's two things. Once you created the cohort, at the next page of selecting of creating your cohort, you can click on create a cohort review set. But if you have already created a cohort, you can scroll down to this pane, select your cohort, for example, the all females.
Mm-hmm.
There's a three dot icon on the left, and then click on review. Okay.
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 Yeah. Thank you.
The next part is we want to create um, concept sets. Concept sets are specific data that you want to measure for your cohort. Okay. So there's a lot of concept sets that we can do, but we have to decide which are the concept sets that we will use. Um, when I was doing my project, the process that I came up with is designing my end goal data set. What is the data set that I really want that will give me all the data required to train my model? Okay, and to do that, I created a simple data dictionary. So I created a demo data dictionary for this so that you will know what I'm trying to say. Okay. So for the data dictionary, similar to what we used. Oh, sorry, I'm not. Is my screen not showing?
It's showing.
But oh yeah, okay. I'm sharing my screen. Okay, so this is. I'll zoom it in to 130. Yeah, okay. So I wanted. So when I was designing, when we want to design our data set, right? What are the attributes that we want? So we want an attribute that we can identify our unit of analysis. In this case, a certain participant, and we also want that particular data set to be what we use to join different data sets together. So we need a person ID. We might need to calculate age at different points of analysis. So we will import date of birth. Um, and then for this particular example, since we just chose females, I will not import sex at birth. But for your other cancers, you might want to import sex at birth. Okay. Um, and then we want to make sure that we get all of the predictors that happened before the breast cancer occurred or your particular cancer occurred. So we need a date of first diagnosis for your cancer. Okay. And then I created this asterisk because it's several attributes. So I need dummy variables for all the diseases that happened before breast cancer occurred. And then calculated variables like age of at first diagnosis, and finally our outcome variable has breast cancer, right? So this is what our model will try to predict. Okay. So now that I have this, I know that I at the very least I need this in my data set, in my final data set. So that's why I was able to analyze that I just need three different data sets. person ID, date of birth, and sex at birth, if needed, are all available in a demographics table, right? So I will need to create a demographics table. That demographics table, I just created a simple code, like I call it dataset A. I will show you later why it's useful. I call it dataset A. I also need a dataset that will tag all the people that have breast cancer, right? I call that dataset B. And I also, um, from my analysis, found out that breast cancer is also a disease. So I need a way to get all the unique breast cancer codes in my cohort and so that I can exclude them from the diseases data set that I will create later. And finally for the concept sets or data sets that we will create, I need a data set that will have all the diseases for a particular patient or person. Okay, I'll call that data set B C, and I will exclude breast cancer from this data set, and I will also need like SNOMED codes so that I can process this data set. So I okay. And finally, um, these calculated these calculated attributes can be done later, as long as we have the relevant dates or relevant source data that we need. So once we decide what are the variables that we need, we can create the data sets. And I will show you how. So to create a data set, you click on this plus sign arrow. Okay. As you can see, there's already an all participant cohort prepackaged. Okay. But we will use our particular cohort that we want for this research, for this study. So we will create the all females cohort that we created earlier. Again, based on our design, we need a demographics table, right? So it's also a prepackaged concept set. Um, and then from that cohort table, we will need the person ID, right? We will need the date of birth. We won't need the race. So that means once we have designed we have designed our data set, so we don't need to import a lot of variables, and it will make our analysis perform better. Okay, and then I can click here, view table, and then so I will just get a table with person ID and date of birth. Yeah, that's what I need. Once I'm okay with that, I create data set. And the way it's useful is just I call it data set A, so that I know because of my design that is data set A. Of course, I will put a description like person demographics, and then save. Okay. I will not. Did I create that? Let me see. Let me just check if I created that successfully. Nope, sorry. I did not save it. I'm so sorry. You can also click on deselect all and then just select what you need. Date of birth and person ID. I'll create the dataset A, person demographics. Then I'll click save. Why isn't it saving? Oh, I didn't click this. I'm not sure why it's happening. Maybe I need to select.
It's not working for me either.
Yeah, I think they have an issue. Um, hmm, that's bad. I'll try again. If not, then we will go to my um, I delete last demographics, deselect person ID and date of birth, create dataset. It's not working. So sorry for that. I think all of us is not working right now.
Maybe you should just preview it before.
Yeah,
Yeah,
I'll
take your
preview it.
time.
Okay. I actually prepared for this. I can also show you how I did it in. So this is how we will create it. I have a pre-prepared data sets later that I can show you the next steps for. Um, or I can log off of all of us and go back. There you go. And then I'll go to create a data set, all females, demographics, person ID, and then not sex of birth, date of birth. Preview the table, create the data set, a sample. So there. Maybe because I was practicing it earlier, I had already created dataset A, but I deleted it. So maybe in one of the servers of all of us, there's still a dataset A and it's not allowing me to save. So I just put in a sample at the end. Okay. I will not click analyze. I will click that later in our next next step when we create our source code. It's a very easy step. So I will now now we have dataset sample A. Yeah.
Yeah, it's
So we can
working if we do like a preview, Vlad.
oh yeah.
Yeah.
Okay. Okay. Now we have dataset A. We also need dataset B. So dataset B, based on our design, are those that have breast cancer. But based on this, there's no concept set that for those that have breast cancer. So for that, we will click this, um, create a new concept set button, go to conditions. So these are all the conditions in the database. They are using SNOMED. You can also use ICD-9 or ICD-10 if you're comfortable with that, but they advise to use their standardized vocabulary, which is SNOMED. So I'll do that. Okay. So I'll just search breast cancer. And for this particular research, we're probably interested in these two: malignant tumor of breast, malignant neoplasm of female breast. Okay. And then I'll finish my review, save a concept set, and then we create a new concept set because I don't think I have an existing one. I deleted everything. So I'll just create a concept set called has breast cancer. And then I'll click save. Now we have a concept set that measures breast cancer conditions from your cohort. So we can create a data set, select again your cohort, and at the bottom you can see that our created concept set is already there. So we can click that, okay, and view. For this more complex tables, I prefer to view it first and then check what I need and what I don't need. So for this particular table, I will need at the very least, a standard concept code, right? To tag, get the SNOMED code of that particular breast cancer. I might need the standard concept name just to guide me what that concept code means. I don't need this condition concept ID, which is not standard. This is just an ID within all of us. And then I also need the condition start time because we needed, based on our design here, we needed the date of first diagnosis. So we need the condition start time, but we might not need the condition end time. Okay, so I'll just delete everything else. So if you like clicking on check boxes, this is a good exercise for you. So there, this is what the data set will look like. Yeah, seems like what I need. So I'll create the data set. I'll call it again based on my design. It's data set B. Then I'll just put sample. Then has breast cancer. And then save. Again, I won't click analyze. I'll do that later so that we have a good demo. And finally, we will create the huge data set for diseases. Okay. So again, I'll create a new data set. And as we see, we have no data set for diseases, a concept set for diseases, and there's also, so we have to create a new concept set, conditions. What you can do, there's a concept set called disease. Just click on that. This concept set, this condition has 590 different diseases under it. So we click on that. If you want to explore what are the diseases under that, there's a view hierarchy button here. We click on that. So this is disease, and everything below are the diseases. So for example, acute diseases, right? There's acute allergic reaction and stuff like that. So it's a tree that has all of these diseases, 590 of those. So we select that, save as a concept set. I will create a new one, and then has disease, and then save. And then we can now create our data set. Has disease. Again, similarly, I will need the standard concept name, the standard concept code, condition start time. Why? Because I want to make sure that I will only retain the diseases that happened before breast cancer. So I need to make sure that they started before breast cancer. So I need the condition start time. And all others I assess that I don't really need. And then I can inspect my data set. And then I'll create that. And I'll call it data set C sample. And okay. Again, we'll leave the analyze for the next step. So there you go. We have done step 3, which is creating of the data sets. Any questions before I proceed with transferring all the data sets to code? If none, then I'll proceed. Just don't hesitate to tell me if you have questions or type it in the chat. Okay, so now we can import a data set into code. We'll just look at click on the data set that we created. So for example, data set A, we click on analyze. If this is the first time that you will export to 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 a code, choose create a new notebook. I'll create a notebook name. For example, I'll do it as a main analysis. This is my notebook name, main analysis 2. I think I already have a main analysis 1. Okay, and we select your programming language. You can use particularly Python or R. For this session, we will choose R. Okay, and then click export. So this is now how your dataset A is exported. It will automatically generate a code to export all the data that you need for dataset A. Okay, so I will go back. Need to export dataset B. So I'll click on dataset B. Click analyze, and then we will select our notebook main analysis 2, and then export, and then do the same. Let's do the same finally for dataset C. Export. Okay. Now we have all the codes to export our datasets A, B, and C into our notebook, into our workspace. I will click on edit, but this will allow me to edit the data and show you some initial preparation steps that we can do on the data frame that I best, what I find very easy. But I want to show you first on the right side of this, you can see this Jupyter Cloud Analysis environment. When you click that, um, this is actually the server that you are running. Okay, so your server, when it's playing, so this is playing. If you click this button, the server will pause. Your server costs 20 cents per hour. When it's paused, it will cost 1 cent per hour. Each of you, for each of your server, you will get a disk storage, which you will put a value on, but the default is 120 gig of storage. Each of you will have, and that will cost you $4.80 per month. Why am I telling you this? Because there might be times when you want to make the server go faster, because we will be processing data for 400,000 all of us participants, and this particular data set is just half of that participants for only females, but it has the disease data set has 38 million rows. Okay, so you might want to increase your compute. So for example, I want to increase the number of CPUs, the number of CPUs from 4, from the default 4 to 8, and I might want to increase the RAM to 30 gigs so that things run faster. But by doing so, your cost per hour increase from 20 cents to 39 cents per hour. So it will go a long way. Your $300 will go a long way. I've done a lot of analysis already. I just spent like $17 for since I think 2 months ago. So you can also enable GPUs, but I don't know if you will need that. I don't think so. By default, your system will pause automatically after 30 minutes. If you want to leave and take coffee first, you might want to increase it to 8 hours. It's up to you. So for this particular session, I will do 8 CPUs and 30 gigs of RAM. And then I'll click next. And it will apply that my cost will be from 20 cents to 39 cents. And it will reboot the server. Okay. So let's just wait. Okay, now we click on edit. Okay, it's running. And it will take some time, but the good thing about this is you're using a cloud server. This server is in Google Cloud. Um, it's in Google Cloud, so you can even do this coding on your iPad as long as you have a web browser. Um, and if you can code on a small screen, you can even code on your phone. Um, so even if your computer is not that big, you can make it big. So I think there's an option here for 96 CPUs. If you need that, I don't think you will, but just in case. Um, okay, let's just wait. While doing that, um, I will open my other research hub code so that after this, if we can discuss some codes with you. Okay, I will just like a good cooking show. I have already made a cooked data set already. No, not this one. I'll go back demo because it's taking time. Maybe this will take analysis. And then I have a main analysis one. Okay. If you're seeing my screen, okay. If you see this, this all of these loads the data set, right? At the end, there's two parts to loading the data set. For example, data set A has two parts, this part, and then another part. And the end of that second part will have a head, dataset name 5. What I do is copy this, and then and then at the bottom, at the bottom, assign that to a shorter name. For example, DFA, because I know that based on my design, it's this dataset A. So I just call it DFA and then paste that thing that I copied here. And I do that for dataset B and C. So that means that you can now have an easier time to access your data. So what's the data frame for demographics again? You don't have to memorize 05392901 underscore person data, right? It's like DFA. An optional portion that we can do as well is to write whatever data frames we have into a CSV file so that later on we don't have to run all of these codes. We can just read them from the all of us data. Okay. Oh, here. So now we have that. We have the. So what do? I will click on this, the add insert cell below. Okay, and then click on this. Go down to go down. Copy this. Sorry. Copy this. And then assign that to DFA. DFA. And then define that person demo graphics. And then I go down again, like this, and then copy this, and assign that to DFB. This is has breast cancer. And then go down again, copy that, and assign that to DFC. And then Jesus. Okay. Let me run all of these for now. And then And then to prepare for writing things into the file system, what you need to do is go to File and click on Open. It will show you the File Explorer. So I'll just delete this for now because I want to demo that to you. So what you see here is I will write what the contents of DFA into a CSV called dfa.csv inside the folder data. So you can create a new folder here, rename that folder to data, and that will allow you um, to access your data frames later. You can start your code actually at this point instead of running all of the download codes earlier because that takes time. Um, and you can also upload external data sets here. So you can go to the folder that you want to upload on and click upload. And it will just say that you cannot upload anything that has PII. So you click yes, I will not. And then it will allow you to, for example, upload the SNOMED database so that you can do some SNOMED-based processing, stuff like that. Okay. You can also, at the end of this code, um, at the end of this code, no, not that. You can also actually export data out of all of us as long as it does not have any PII. So, for example, your data frame drop the patient ID, and then just make sure that it's all just dummy variables. And so to do that, I can create a new folder. I name that export so that I know that these are the files that I need to export. So rename this to like export. Okay. And then I save all of the files that I want to export in this folder. To export a data, so for example, I want to export this dataset A code. I just click on download, and it will tell you that you have to make sure that you're not exporting PII, and then just type affirm, and then OK, and you can export
Hey, hey, Vlad.
data. Hello. Yeah.
Hey, it's Aaron. Just curious because in the demographics it actually had a date of birth and not just an age, like a pure age. I realize
Oh,
it's not associated with a true social security or some form of real identity. It seems like the patient ID has probably been masked in some way. So is that accurate to
yes.
say it's not PII, or would that be considered PI in this context?
If
Because all of us during the training, they said that there are some combinations of data that can still be tagged as PII. So, but at least when you're um, running the registered tier data, all the dates have been shifted. So the date of birth is not actually the actual date of birth. Um, yeah. So yeah, you can also export the person ID if you want to join other datasets on that later. I think they're also masked, but just be wary of any of combinations of data. They say that some combinations of data can still identify a person during the training. Okay, now it's run. So I'll just click on this so that we can write the CSV and show you that it will do it. Okay. So this data already, the data folder already have the CSV files. Okay. Now, if you have already written those CSV files, the next time you access all of us, you don't have to start from line 1. Just scroll down to this line, for example, and then read the CSV files that you have created. And that will save you like, yeah, I think 15 minutes at least. um, now we have we have some steps on data preparation that I've prepared, but not all. Dataset C was so big that I only was able to do some, just solve some of the issues like early this morning. But I can share it with you later, um, when we have time. Okay. So the first thing that I wanted to do, I explored data frame A. I found out that date of birth, when I look at this date of birth, the times, the dates that we downloaded are in character format. We don't want that because we want to have operations on the date. We want to make sure that the date is a date format. So we change that date of birth to a date format. Okay. So that's what this does. Mhm. It's just taking a long time. Okay. And then um, we also now we also found out, I also found out that the data frame A, the demographics data frame, does not have any duplicates in terms of person ID. So I did an external analysis that's not coded here. So I made data frame A as a basis of my analysis data frame, right? So this analysis data frame is this data set, this data input file. So data frame A without any processing, I put that here, and I will just join all the other data sets to DF analysis. Okay. Uh-huh. Now, now we process the cancer data set. We process the cancer data set. We want to find out the earliest date of diagnosis, date of first diagnosis based on our design, right? We wanted to have a date of first diagnosis. So to do that, again, I made sure that the condition start time is a date. And I aggregated, if you still remember SQL, I aggregated based on group by person ID and then get the minimum condition start time and rename that into date of first diagnosis. Okay? And that will give me a data set of all the persons and their first diagnosis for breast cancer, all the persons with breast cancer and their diagnosis. And finally, I can left join this aggregated breast cancer data frame to the DF analysis. I do left join, meaning if there are persons in DF analysis that does not have cancer, it's okay for them not to have a date of first diagnosis. That's what we want. But if they have a date of first diagnosis from data frame B, then we have to just copy that over. So yeah. We also wanted to exclude all of the breast cancer standard concept code. So this is not condition concept ID, standard concept code from the diseases, right? So I created an exclude data frame. And from the diseases data frame, I excluded everything that all of the diseases that have the concept code for the breast cancer. We are also only interested in diseases that happened after the cancer diagnosis. So in this data frame, in this code, what I did was I got
You
the
mean
cancer
before?
before, sorry,
You mean
that
before?
happened before. Yes, before, only the diseases that happened before the breast cancer. So in this data, in this code, what we did was um, we got the diseases data set, and I added a new column on the right for date of first diagnosis that came from DF analysis, right? And then I only retained those that happened before the cancer. right? Condition start time is before the cancer. Or if you didn't have a cancer, then of course I also need to know what are the diseases that you have, because that might be um, relevant. So and finally, and then I think the next step is um, I grouped again. I grouped again this data set. I keep aggregating them so that I reduce the number of rows so that the next processing will be more efficient. I group them again based on unique combination of person ID and disease. Okay, and then I just needed the minimum diagnosis date of that disease. So a date of first disease, I call that date of first disease, and retained the standard concept name. And then the last analysis that I was able to do, um, I created a new column called disease group so that we can group similar diseases together. My plan was to aggregate based on that disease group. Otherwise, for example, or for arthritis, there will be a left knee arthritis, a right knee arthritis, both knee arthritis, but we would just might want to tag that as arthritis. So I wanted to have a disease group called arthritis, but I wasn't able to finish that in time. Um, yeah, so I can show you later after Dr. Alemi's message to you during your labs. I can go around if you and then show you the code. Yeah.
Well,
Okay.
let me say a few things. First, Vlad, this is the most significant, the best lecture I have ever listened to on how to organize a database in all of us. You really have you can't imagine how well a job you have done.
Thank you
And
so much.
I hope the students in class realize how much this is helpful. So I really appreciate what you have done, Vlad.
Thank you so
Uh,
much.
Now, if I could share my screen.
I'll stop sharing now.
So you see my screen, right?
Yes.
All right. So let me see if I can increase the. Okay. Let me start with a couple of things. Uh, this this course is organized in a particular way, and the purpose of this project is to test your knowledge, show us that you can do these kinds of things, and to help you to deal with real data as opposed to toy data or fake data. But this project is not your dissertation, even though some of you have chosen a project that's close to your dissertation. I want to emphasize that in this project, we are asking you to follow our recommendation on what variables should be included and how those variables should be aggregated. We are not asking you to be creative, to be exploring, to, to be a scientist. These are not things we are asking you to do. We are asking you to follow instruction on how to create this database. What Vlad showed you is the instruction. Now, there are some modifications, I would think you would want to have male and female in your database. I would think you want to have race in your demography. I would think you would want to have ethnicity in your demography. Those things I, I would include. Uh, but the key aspect that I am emphasizing now, and I want to be very clear about, is that you do not include any other variable besides disease. There are two reasons for it. First, diseases are the variables that are available in electronic health record, and we want all the projects to deal with EHR kind of data. But second, when you include other variables like surveys, like other genetic or non-genetic surveys, your data structure uh, balloons. So for example, if you include a survey and the survey is collected on 1,000 people and you have the EHR data on diseases on 400,000 people, then your the data frame that you're dealing with is 1,000 times 400,000. It's not that these data are tables and you can easily do these kinds of things. And we don't have time in this course to spend on you coming and complaining and saying, oh, my data is so large, I can't analyze it. I want you to stay simple and with the kinds of things that we have shown you, we want you to include, which is only as independent variables are demography and diseases. And when we want you to exclude from independent variables, as Vlad has shown, any variable that's related in the definition of the outcome. So that's a very important step that he has demonstrated. We want you to merge these three different data sets into one set, which we call it the analysis data. And then we can go over this. So that's my first point. The project is not your dissertation. Please follow the instructions. Don't be creative and follow. There will be time for you to be creative. This is not the place to be creative. So this project is designed to teach you certain topics and evaluate your knowledge of what has been discussed in the class. So what are these topics? One, we want you to learn how to clean the data, how to organize data, how to clean the data. This is not a simple instruction. This requires a lot of insight into the data. And this project, some people think, oh, we are going to do a regression. This is not a regression project. This is far bigger than a regression project. This is real analysis. And you are expected to clean the data in a particular manner. And here you can introduce some creativity and say how you want to clean the data. For example, I noticed that Vlad's data analysis did not include survival and date of death. And that is one
Yeah, yeah.
variable that you want to include there. And when it comes to date of death, there are errors. So if the person has died and yet there are conditions that have occurred after date of death, those are considered unusual data observations. And you have to decide whether you drop the person or you drop the conditions after date of death. Usually, there are some conditions that continue after date of deaths because even though the person has died, bills are coming in, conditions are getting coded into electronic health record. So the first month or two, you could have conditions on the patient. Uh, then there are also conditions that are coded because of the family of the patient and under the patient's medical record. So all of these create unusual situations for you. So you have to clean the data the way that you see fit and proper. And there you can use your intuition and insight to direct you. Number two is how to measure variables over time. So one of the things that Vlad has shown you is that all conditions, all independent variables must occur before the dependent variable, which is cancer. Now, what does that mean? Age, gender, race, these are all set at birth. So they are occurring uh, prior to your outcome. But conditions, you could have cancer and you could have infection after the cancer. Those are those infections that occur after the cancer, they are no longer independent variables for predicting the existence of cancer. So you have to drop those, and Vlad has shown you how to do so. This is really important, but it goes beyond this. If you want further analysis at some point, you may want to look at the order of the conditions themselves. So, for example, if the person has infections now, but after the infections has diabetes, that's one order. And another order might be that they have diabetes now and infection later. All of these things are possible. All these kinds of creativity is possible, and I look forward to your creativity in doing these kinds of things. But first, do the simple analysis. First, do what we are asking you to do, because it seems simple at first, but to do this will take you months. The third step that we want you to learn is how to create features in the database. Now, we haven't discussed this yet, uh, but in doing data mining, in doing large scale data analysis, you have thousands of variables. Here you have already limited the 140,000 ICD-10 variables into 590 conditions, which are the diseases which we are using to predict your cancer. So even these conditions, we have now 590 conditions, and these conditions have a hierarchy, SNOMED hierarchy, and we want to use that hierarchy to create progression of diseases in body systems or across diseases. So, for example, the concept that you may have a disease like COVID, you may have a disease like influenza, and you may have a disease like RSV. These are all three an infectious disease. So we want to see if the progression inside infectious diseases is a contributor to your cancer. There are lots and lots of papers that show that infections are related to cancers or are markers of cancers. So repeated infections and progression of infections show immune body system weaknesses and therefore might be a good predictor of your cancer. So one of the things that we have to teach you yet, and we haven't gotten there yet, is how to construct these features inside your database. So that instead of 590 conditions, you may end up having 20 progression of the disease in body systems. Obviously, one of the things that we want you to show and know, we want you to check your assumptions. And by that, I mean that the dependent variable is binary, that you don't have multiple variables for your dependent variable, and that your independent variables are normally distributed or nearly normally distributed, and yet your residuals, most importantly, is normally distributed, and the relationship between these variables is linear and monotone. Monotone refers to the fact that every time a disease occurs, a condition occurs, it should either not uh, uh, not decrease the risk of cancer, but could keep the risk, not have an effect on risk of cancer, or it could increase it. As long as it increases it or has no effect, that's an okay variable. If it decreases it, you have to switch the binary variable so that it always increases them. We haven't gotten to this part of the class where we look at the monotonicity of the variables, but when we get to multiplicative modeling, that becomes really important. You have to also show visualization of the data. Every time that a student has come to me and said, well, I don't know what to do, and my first answer to the student is, show me the data. Print the first 4 lines of your data. And then after that, show me graphically the distribution of your data. All of this has to be done by you and examined before you do any regression analysis. One of the things that we need to cover is a concept that we have developed called corner cases, that comes from the work of Raifa and Keeney in Harvard on multiplicative utility modeling, but that we have applied it to regression analysis. Corner cases refer to identifying inside your data a combination of variables in which one variable is at its maximum and every other independent variable is at its minimum. So the minimum is always 0, the maximum is always 1. So one variable being at its maximum, the corner case is unique in understanding the data structure because it tells us what the coefficient should be for that variable when nothing else is involved. And we will go over this, but one of the things that you have to do is to identify these corner cases and to identify that you can fit the data properly to these corner cases. One of the things you have to do is to examine interaction terms. And by that, I am referring to all pairwise, triple, or if you can, quadruple interaction among variables. And by that, I am referring to multiplication of x1 times x2 and x1 times x3. Each one of these pairs provides you a pairwise comparison. So if you have 590 conditions and you want to take these conditions 2 at a time, you will have a lot of pairs of conditions. And if you also include triples, and if you can include quadruples, you are talking about a lot of variables. When you have a very large number of variables in thousands, you are talking about high dimensional data analysis. And that's where lasso regression comes in. And I don't think we have covered lasso regression, have we?
So it will be for next Monday.
Right. So you don't have all the tools necessary to make sense of this database right now, But next Monday, we will introduce you to Lasso. And I think maybe 2 weeks from the Monday, we will introduce you to multiplicative modeling and corner cases. And finally, you have to do your regression, interpret progression in body system and their findings, and the goodness of fit, and show that variation in your cancer can be predicted from the independent variables. There are then 2 other steps: prepare your report, provide your presentation. Now, you have already written the first part of your report. The next part is your method section that is due maybe this next week or the week after. Uh, you are expected to write the method section before you do your analysis. So that's something that you need to do. Okay, so that's your project for the semester. It's not an easy thing to do. I have done this in one previous class without Vlad's help, and it was havoc because people get themselves into corners of these databases and they can't get out of their R code or Python code or whatever they are working on. Let me pause and see if I am understood and how we can help you guys. And then if there is no comments or questions from me or Vlad, then you're expected to start doing that, the creation of your database tonight. Uh, so any questions or concerns?
Professor, this is Aaron. I want to thank Vlad. Obviously, he did a fantastic job. You mentioned a few variables that we should include, such as race and ethnicity as well. It may be beneficial for consistency's sake if we just had a written, I guess, inclusion criteria, for lack of a better term, to ensure we all select the same items for our database. Is that reasonable or a reasonable request? Over.
Yeah, absolutely, Aaron. That's a good idea. Uh, the the thing, I can make the list verbally right now because tonight you're working on your databases, but I will also email it. The list should include age, gender, race, ethnicity, survival, birth, uh, uh, and after that, conditions, the same way that diseases, only diseases, nothing else. Um, and that's it. I'll make an email to the class, or Vlad, you can make an email to the class listing these.
Okay, Dr.
By
That's
the
Edgar.
way, guys, I just want to tell you that I am in Ireland, talking to you from Ireland. So I'm
Yeah.
very happy to be able to talk to you guys. Any other questions or comments? I will wait a few more minutes before we release, assign everybody to work in different rooms. Uh, does anybody not have access to all of us database? Okay. Okay, Vlad, should I assign them to 3 groups of 3 and
Yes,
1 group of 2? Okay,
yes. And I
and
will
then
stop
we can
recording
do that.
now. Okay.
Yeah, please stop recording. And